Our next speaker is George Bye, CEO of Bye Aerospace. He is the founder of Bye Aerospace and has 2 decades of experience as an engineer creating advanced concepts, including the 14-foot wingspan solar electric aircraft Silent Falcon and the current all-electric eFlyer family and solar electric piloted Solesa designs, now in development and FAA certification process. Previously, George led ATG, the company that launched and developed the Javelin, a transonic 2-seat jet for military and civil utility, and he holds a design patent for the Javelin, which first flew in September 2005. George has a BS in engineering from the University of Washington, go Dogs, and is an ATP-rated pilot with over 4,000 flying hours. He was a U.S. Air Force instructor pilot in the supersonic T-38 for Euro-NATO Joint Jet Pilot Training, a C-141B aircraft commander, and is a Desert Storm veteran. And he is a longtime supporter of this conference, and for that I'm very grateful. Please welcome George.
Yolanka has introduced me, I think, 4, 5, 6 times now, something like that. And I think she finally got Euro-NATO Joint Jet Pilot Training correct. I mean, you got it. That's awesome. Euro-NATO Joint Jet Pilot Training, NJEPT, is based in Texas, Shepherd Air Force Base, still today, flying the same jets that I flew back in the 1980s, from 1983 to 1988, almost 1989. Going back a little further, when I first learned to fly, I was about 8 years old, and my mother taught me in our little Piper Cherokee 140. And later I got my license, was inspired to fly, became a pilot myself, went into the Air Force as we just heard. But that Piper Cherokee 140 is still flying today. As a trainer today. And some of the pilots that I flew with then are still flying today. But all of us, including the fleet, is nearing the end of our useful life. The point is, I think we are all here because we love aviation and innovation. The technology that we look at, from large companies to small, 2 people, 20 people, 200 people, or 2,000 people. It's interesting, it fascinates us. We just celebrated yesterday, of course, landing on the moon, some 50 years ago. Sadly, it was 50 years ago that we last landed on the moon. I mean, that's cool, but it's also troubling, isn't it? In our industry, in aviation, general aviation, much of what we are today is the same as it was 50 years ago. Our average fleet age is 50 years old. When Bye Aerospace looks at innovating, we look at innovating with a purpose against a pain point. We were talking about mobility just a minute ago. Let's step back and talk about mobility for just a minute more. Right now today, our 50-year-old fleet and the pilots that we all are older than 50 years old. In fact, 30% of us as airline pilots, those of you who might be an airline pilot, I'm an ATP myself, 30% of us are retiring in the next 3 years. We talk about mobility. Getting on the United Airline flight from Denver to Chicago is going to be very difficult when 30% of our airline pilots are retired over the next 3 years. Oh my goodness, you want to talk about mobility? The ability to get to New York or Dallas or Denver or Los Angeles is going to be challenged without new pilots. Bye Aerospace, in developing the eFlyer, has in mind, has in focus, pilot training as our #1 top priority. Not transportation in and of itself in the sense of mobility specifically with the eFlyer 2, but rather creating the environment, the industry that we all know and love as the place where new pilots are nurtured or trained and can become part of the industry that we all love, starting with general aviation and of course going into the transportation industry as part of the opportunity to transport us across the US and around the world. eFlyer 2, when we spoke last year, had just begun flight tests with the V9 motor. And V9 meaning the Siemens, now Rolls-Royce. Some of you heard during the Paris Air Show that Rolls-Royce is in the process of purchasing Siemens E aircraft or the motor production process. So we had just begun flying last year. We continued that flying through this time frame last year. The airplane flew great, but it was a pre-production motor, rating a little bit lower than what we have today. This last spring, we put the production motor on the airplane, the V10, full production SP70 electric motor from Siemens, now Rolls-Royce, on the airplane. I'm very proud to announce that we have now started flight tests with that production motor, and oh my goodness, 20% more power is really cool. And Rob, I'll point over to you. By the way, in terms of efficiency, 90 knots at 35 kilowatts. Pause, think about that a minute. 90 knots at 35 kilowatts. You think, well, that's kind of interesting, that's kind of cool. But you know what? That's everything. That's everything. That's the business plan. That's electric aviation with wings. That means I have 3 hours of flying time for real. That means I have 135 knots or more top end. That means at 80 knots, 76, 78, 80 knots on average, I have a flight training mission to train those new pilots and do it over 3 hours with reserves. That little nugget of information is validating to the whole thing. Now I have an L over D of 20.6. So that 450-pound payload that we're carrying is done so with the benefit of airfoils. So the amount of energy I need to use to carry aloft 450 pounds is nicely distributed over a very efficient airfoil aspect ratio, which translates to L over D. The benefit of general aviation electric aircraft is wings, as opposed to eVTOLs, which of course we've worked on and many of us have worked on to try to make more efficient. That's hard to do. At least for a period of time, I've got to lift directly. I have to use all the energy to get up off the ground, as opposed to an aircraft, of course. But our mission is not mobility with the eFlyer 2. Our mission is training with the eFlyer 2. Now, likewise, since we last met, our team has doubled in size. Our market has tripled in size. That's pretty cool, too. OSM Aviation out of Norway, Norwegian Airlines. Yes, right here, of course, Eric. We have our friendly Norwegian friend here with us. And talk all about Scandinavia and Norway specifically. But Norwegian Airlines, an OSM group, OSM Academy under OSM Group, ordered 60 eFlyer 2s a couple of months ago. That's pretty cool. They recognize, and Scandinavia in particular, is interested in the benefits of electric aviation. Electric is clean, no CO2. Electric is quiet. One of the things we found as we went from last year with that smaller motor and the two-blade composite prop back to the larger motor, the production motor, the SP70 production motor that's on the airplane now, and the three-blade prop I'll show you here in a second, is that we got that noise signature back down. So much so that the airplane taking off literally right in front of me, 500 feet away, is not detectable to the human ear. I love that stuff. And we all do too. Half of our training airports, half of the general aviation airports across the country are in urban environments. In a couple of weeks' time, I'll be speaking to the Greenwood Village City Council. Greenwood Village is right across from Centennial Airport. And Robert Oleslager, the airport manager, hears from the city every week about how noisy those Cessnas are flying overhead, doing their training mission at Centennial Airport, where we're based. They are so excited to talk to me about electric aviation, not just because there's no CO2, but also because there's no noise. And certainly at the community level, electric aviation matters here in the US, around the world, and again, just to mention Norway, and specifically in Scandinavia in general. Oh my goodness, are they leading the charge? Did you catch that? They are leading the charge in Europe. They view electric aviation as essential, not interesting, not nice to have, but as essential. And they have programs there. OSM Aviation and Eric, who's our distributor and partner there in Norway and Scandinavia more generally, they are really working hard to bring the benefits of electric aviation to pass. So let me give you some interesting images and a few more details. There's been some great media coverage recently, some videos, some updates from the various messaging and press releases that we've had. Some of what we're sharing is kind of amongst us. Some of the technical aspects are a conversation. We try to be very transparent because this is kind of a special technical group. So just kind of keep that in mind. But as I mentioned, we've more than doubled in size since we met last. We've had some nice venture capital come into the company. We have a new R&D facility and hangar facility. And as we just mentioned, the airplane is now flying with the SP70 motor in it. The team has grown, as I just mentioned. We're so proud of this amazing team. And of course, having a vision, being a pioneer for what comes next is only realized when you have the team to execute the plan. I think amongst those that you see on the slide, we probably have about 30 aircraft programs that we've taken all the way through from design, preliminary design, to the critical design phase, all the way through certification to market. So just a fantastic team that I'm honored and privileged to lead. The three-blade prop from Hartzell is not our production prop. It's still a prototype propeller, and we're also looking at a couple of other propeller blades there. But that has helped reduce that noise signature by distributing the load from the motor across more surface area, more airfoil and blade area. So that really helped not just the RPM, but also helped the noise signature of the propeller component. The motor itself, of course, is silent. And also notice how sleek the nose of that airplane is. Isn't that awesome? It also makes it a pretty airplane. But we have in mind with the eFlyer 2 to address this very, very great challenge. 790,000 pilots are needed over the next 20 years. We have 150,000 today, and many of us are retiring, as I just mentioned. How are we going to bring, as a general aviation community, the next generation of pilots through the pilot training process? It's on us. And that legacy fleet at 50 years old is going to be really challenged. 8 times more production in the annual output of airline transport pilot. We have an expense to address for pilot training. Right now it's about $150,000 to $200,000 to complete your training to become an airline pilot. I think it's pretty obvious to say the number one reason why students drop out of pilot training is because of cost. It's not just the age of the airplane, it's the cost of the fuel, it's the cost of the maintenance, all of which, of course, is a burden that ultimately the student pilot who's paying for training has to bear. And of course, the great benefit of electric aviation is that the cost of electricity is so much less than the cost of aviation gasoline. In Colorado, it's about $3 per flight hour to fly, as opposed to $45 or $50 or $55 of aviation gasoline per flight hour to fly. So we're flying now. It's not a concept. The numbers that we're achieving are real and demonstrated today. Gotta keep doing this. The clean technology aspect of what we're doing from a customer perspective is a big deal. When we first started talking 5 years ago, 10 years ago, this was kind of an interesting conversation, but there wasn't the cultural shift that we've seen until really the last 1, 2, maybe 3 years. The fact that this high technology machine that's going to train the next generation of pilots is clean and quiet is a big deal today, much more so than it was a year, 2, or 3 ago. So the overall characteristics, again, with the electric motor, from Rolls-Royce, now we say, it used to be Siemens, of course. We have a full airplane parachute. Of course, the ability to be ruggedized and easy to fly is essential for the training mission. But I would also add, it's kind of interesting that with the 46-inch wide cabin, we also have full-time environmental temperature management. For the first time in a 2-seat trainer, we have air conditioning. And for those of us who train up in Norway or in Canada, we have cabin heating. Now, part of that's because over the last couple of years of research in flying electric, we really want to maintain thermal management of the motor and batteries. And so to develop a full-time thermal management system for that aspect, and the life of the battery and motor, that translated to the opportunity to have a comfortable cabin. And of course, with an instructor pilot who's flying at least probably 2 times, if not 3 times a day, a comfortable cabin is a big deal. So eFlyer 2 is enabling flight training, and against the competition, about 1/5 the operating costs, about $23 per flight hour, including maintenance and the energy cost. Looking at the problem to solve, the size of the market, about 60,000 units, addressable market, 20,000 units for a target market, and about a $9 billion market for those units. So a sizable business case behind the innovation and the problem we're trying to solve with the eFlyer 2. Now, look to the future. One half step further. Take the digital design of the eFlyer 2 and stretch it to a four-seater. An all-electric four-seat aircraft, a Cessna 152 to a 172 to a 182. And you can see very quickly the utility and the possibility of an eFlyer 4. And again, with the disruptive aspect of cost, the energy cost specifically being so low, it compares in a dramatic way to the conventional or legacy aircraft flying today. We show the Cirrus and the 182, of course, but there's many other four-seaters. With a 2-hour flying time at 165 knots, a 4-hour flight time, actually over 4 hours altogether, but if you're specifically targeting the mobility of people in a high-density urban environment, the opportunity to fly fast and get a mission accomplished, whether it's a private pilot or somebody in a Part 91 or Part 135 operation, the possibilities get very, very exciting. One of the things that happened since we spoke here last is that Blackbird, which is a air taxi operated out of San Francisco, did an agreement with us for 100 eFlyer 4s, 10 eFlyer 2s. So this is a dramatic capture of an important market for moving people around a high-density urban environment. For Blackbird at San Francisco. Just this last week, we signed up another air taxi company in the US. 15 eFlyer 4s, 2 eFlyer 2s. Very exciting. We've got 2 more in Europe that we're talking to as well. The ability to move people and cargo with economy and speed with no CO2 is an exciting possibility for the immediate future. So, Yolanka, I don't know if you remember where we were last year, but you can see the number of units that are reserved with the company has grown immensely. And of course, we appreciate all of you and those in the media who have helped get the word out about electric aviation. This is a part of the reason why there's been such a wonderful response here in the US and around the world. So the production motors in flight test, we're going to be using the Garmin G3X, not the Garmin 1000, but kind of the brand new next generation Garmin G3X. We're well underway. We're over a year and a half now in the FAR Part 23 certification process. Again, eFlyer is not an LSA. It's not an ultralight. This is a full certified Part 23 airplane. As I mentioned, we have the new facility that we're operating out of and flying out of. The OSM group and the Blackbird large market orders, and of course many more in the hopper to come. You kind of wonder, well, George, what follows? I mean, what's the next step? And it's fun when you think about the eFlyer 4, retract the gear, fly a little higher, fly a little faster, and fly a little pressurized with great comfort. And of course, you take that eFlyer 4 and you make it even a better airplane, we think. So look to the future with me. We do it, we win together, we collaborate together. That's what it's going to take to change the future. Thank you very much.